Hello and welcome to a new episode of a series where we're recreating the classic game of columns using SpriteKit. And today I want to implement levels. So as the game progresses, its speed should increase, increasing its difficulty, but also probably provide the opportunity to score more points and also give a sense of progression by seeing that you're improving at what level you are. So to get started, I'm going to start very simple with stating in my test. So I'll create a section for levels. And the first test will be that a new board starts at level 1. Okay, well, thank you Apple Intelligence by providing indeed a reasonable suggestion. Let's see. Okay, we can't compile because we don't have a level variable yet in our board. No problem. Let's go to our board and add a variable for the level. So we have a level and we'll start at 1. And now this test should now pass. Okay, so the test passes. Now we need to think a bit about what makes us progress to the next level. We could use something like time. So after a fixed set of time, then you automatically go to the next level. Or perhaps reaching a certain score threshold to go to the next level. But I'm going to choose a number of how many times a new set of columns was spawned. So some amount of new gems that get spawned in the game, we go to a new level. And that means that we somehow need to keep track of how many times that happens. So I'll create a second test that says a new board has a spawn count of 0. So it started 0 because nothing was spawned yet. So we have a board and the spawn count is indeed 0. So we don't have this variable yet, but we can quickly add it and also get this test passing. So far so good. Then let's see what we need to decide on a spawn count where the level increases. I'm going to start at 10, so after spawning new gems 10 times, we go to the next level. So let's create a test that says when a board reaches a match spawn count of 10, it increases the level. So we have a board, we set the spawn count to 10, then we update the board, and then we assert that indeed the level is 2. Oh. And that was already provided to us by Apple Intelligence. So let's go. Now this test fails because we never update the spawn count, but this is something we can do quite easy when we are, let's see, we are spawning new gems. We increase it by 1. Okay, next test. Oh. First, let's make sure the test actually passes. So in the update, we are only updating the spawn count. Do we already have a test for that? I don't think so. I think we solved the wrong thing. So I'm going to get rid of this one. What we need to do is change our update function. So let's go to the update function and let's create let's say we have our matches here. If the spawn count is greater or equal than 10, then we increase the level. Let's run the test again. Okay, now the test passes. Now what I also want to test is that when our board levels up, spawn count is reset. So we have our board. We set the board.spawn count to 10. Then we update the board. So we have our updated board's spawn count that should be less than the board's spawn count. Let's run the test. We can set it to 0. And now the test passes. Let's put this in its own function. This will be update level. And this can be a mutating private function that doesn't need this anymore. And we can call it as updated board. And this should still, if everything goes well, should still work. Let's see, test fails. This is a flaky test. This is something we will fix next episode. I know what's going on there. Okay, then when a new set of gems is spawned, spawn count is incremented. So we create a board. We update the board and assert that its spawn count is larger than the original one spawn count. So let's run the test. And this is actually what I was accidentally implementing earlier. Oh, I don't need to test here, I need the board here. So let's see, where am I creating the new gems? Here I can update the spawn count by 1. Let's see if this works. Okay. So we now have level progression in the sense that every 10 spawns the level increases, but other than increasing a number it has no impact yet. So let's make it that if you score a match at a higher level you get more points than at a lower level. So making a match at a higher level increases the score more than at a lower level. So we need a level 1 board, and this one needs some gems. Let's see, we can put them at, for instance, 1 and 0, and they can be green. Can put one at 2 and 3. Then we have a level 2 board, which is the level 1 board dot update. Oh, that's an easier way of doing this. We can just say we take our level 2 board and we set its level to 2. And then we assert greater than that our level 2 board, if we update it and then take the score, is bigger than our level 1 board when we update it and take the score. So let's see. So this fails. Let's see how we can get some more score in based on the level. We have a function called update score. Let's not just multiply the number of matches by the combo multiplier, but also by the level, and this should be enough to pass the test. Okay, next test. Then I also want the speed of the game to increase as you progress in levels. So let's say that our new board has an update delay of half a second. So we take a new board and we assert that the update delay is half a second. And this one, of course, fails because this is a new variable. So let's create a variable called update delay equals 0.5. And now this test should pass. Then let's make it so that after a level up, the update delay is reduced. So we have a level 1 board, and we have a level 2 board, that can be the same as the level 1 board, but only with the level set to level 2. And then we can assert that the level 2 board dot update delay is less than the level 1 board's update delay. Let's see. This one fails, but we can fix this kind of simple by saying, okay, this one returns, we compute it as a time interval, and we say that the result is we can just return 0.55 times meaning at level 1 we get 0.5, and as level increases we linearly take down the update delay. Okay. Then the final test is going to be that update delay never goes below 0. As this is a linear series, as level increases, of course, we're lowering the update delay, and of course at some point in time this crosses the 0 axis, so I need to make sure that I don't want to mess around with update delays that are negative. So I'll write the test. So we take a board. I'll set the board's level to a really big number, and then I'll assert that a board.update delay is still larger than 0. Let's run the test. Okay, so this test fails. We can fix this by saying the result is this, and we just return the maximum between the result and 0. And now the test should pass. Let's see. And it's still fails. Let's give it another go. Oh, it needs to be greater than or equal, because we say it never goes below 0. Okay. Now we have this level functionality. Let's add it into the game. So our game scene currently has, we can get rid of this one. Our game scene currently has a hard-coded update interval. Let's use our board's update interval. So we can make sure this returns a time interval, and we return the boarded update delay. Let's see. Then I also want to be able to show the level on the screen. So I'll make a new published variable called level that I'll set to 1 to start. And I'll make sure that level equals board.level at each update. And when I reset, I also set the level to board.level. Then in our content view, I think we can change the level to use the scenes.level. Do I need more than this? I actually don't think so. So let's build and run and see what happens. So we start at level 1 with a score of 0. So let's see. This takes a bit of time because we need to see a new stack fall 10 times. So this one only 3. I think we should be nearly there. So we're now at level 2. You can't really see the speed difference yet because it's such a minor difference, but I think it does already feel a bit faster. And if we play for some time, it will feel even more so. Also notice that scores are increasing faster now because we're at a higher level. So we're at level 3 now. And the scores are going faster, but it's definitely feeling faster now. And the combos really help increase the score. Now let's see how far we can go. I'm not talking that much now because this is actually eating up a lot of my concentration already. Okay, I'm going to stop here. I think it's obvious that the speed was increasing. We almost have the complete game now. Next time I want to add the feature that you can see what the next gems are that are going to fall, and also fix the bug with one of the testers that regularly fails. And that's the one. It fails because sometimes gems are spawned that are 3 of the same type and then immediately get removed again. And that's something actually I want to prevent in the spawning of gems going forward. So that's something we can do next time. For now, thanks for watching and have a great day.